This is the AP Calc AB 2019 FRQ number 3. What we've got here is a graph of a function f, and the problem tells us that the continuous function f is defined on the closed interval from -6 to 5. The figure above shows a portion of the graph of f consisting of two line segments and a quarter circle centered at point 5,3, which is right here. So there's its center, and it is known that a point 3 comma 3 minus root 5 is on the graph of f. So for some reason, which we'll probably find out here soon, they've given us one specific point right here that lies on the circle. Okay, here's problem A. It says if the integral from -6 to 5 f of x dx is 7, find the value of the integral from -6 to -2 f of x dx. Show the work that leads to your answer. All right, well, I'm going to take a look at this from a graphical standpoint first, and then you could also think of the solution to this non-graphically in terms of setting it up. Obviously, we're going to have to use geometry here to calculate our integrals, but let's look at this from a graphical perspective to set it up. Now, they're telling us that this portion that we don't see, which goes back to -6, they've given us the area between the x-axis and the function f to be 7. So in other words, if we were to take the whole integral here, this integral here from -6 to 5 f of x dx, that whole area there is 7. Now, what are they asking us to find? They're asking us to find the integral that's just from -6 to -2. They're asking us to find this. So they want us to find this area. But they've given us this whole entire area. Okay, well, what does that mean then? I think it's pretty apparent that we're going to take this 7 and subtract out this area right here. So we need to calculate all of this area here and subtract that away from the 7 to give us this area that we're looking for. Okay, so that's basically what we're trying to find. Now, another way to think about this, though, even if we're not really looking at what the integrals mean, if you tell me that I need to find the integral from -6 to -2 f of x dx, okay, and you have given me a value for the integral from -6 to 5 f of x dx, well, if I need to transform this integral into the one that I'm looking for, I'm going to add the integral from 5 to -2 f of x dx. Because one of the properties that we learned about these definite integrals is that if I integrate from a value to another value and I pick up at that value and go to a new value, the end result, the net result, would just be from -6 to -2 f of x dx. Okay? Now, how does this that I've just shown you, which really had nothing to do with the graph, but just by using properties of limits, how does that jive with what we just determined graphically? Well, if we change this plus to a minus, basically what we're saying is the integral from -6 to 5 f of x dx, which again, they told us what that is, that's 7, and I change this to a minus, I can flip the order of these limits of integration to go from -2 to 5 f of x dx. That right there is what we had already determined by looking at the graph, taking the whole integral from -6 to 5 and then subtracting out the integral from -2 out here to 5. Okay, so let's do that. Well, I'm going to substitute 7 in for this integral that they gave me, and I am going to subtract, and I'm going to go back to the graph and find out what this area is under the curve from -2 to 5. All right, let me get rid of this stuff here. Now, as we look at the area going from -2 to 5, I'm going to start off over here. This area is exactly equal to this area, so I don't need to bother calculating those areas. They're going to cancel each other out because this area is above the x-axis, this part's below, so the net is going to be 0. Likewise, when I come over to this triangle here, its area is exactly equal to that area, so their net integral from 0 to 1 is going to be 0. So what I'm concerned with, the only thing that I really need to be concerned with, is I need to find the area of this trapezoid, which is going to be very easy, and I need to find the area that's underneath this quarter circle. Well, how am I going to do that? Very easily. I'm going to find the area of this square, and then I'm going to subtract out the quarter circle area. That net will leave me, that's going to leave me the area that I need over here. Okay, so let's start on that. So what we're going to do is we're first going to put in here the area of the trapezoid. Well, this trapezoid, its two bases have heights of 1 and 3. So this is going to be 1 plus 3 over 2. And then I have to multiply by the height of the sideways trapezoid. And the height is just this distance along the x-axis, which is 1. Okay, not too bad. Now, I'm going to add in the area of the square, which is a 3 by 3 square. So this is an area, we'll call it 3 by 3, right? So 3 squared, that's the area of the square. But then I have to subtract out the area of the quarter circle, because that's not part that's under the function f, between the function f and the x-axis. The area of this circle would be pi r squared, or 9 pi, but it's a quarter circle, right? So it's basically 9 pi over 4. Okay, this expression here is the proper answer that's going to give me the integral from -6 to -2. So what I've got is 7. 1 plus 3, 4, divided by 2 is 2, so that's 7 minus 2. 3 times 3 is 9. I'm changing the sign because of the distributing that minus, so that makes that a minus 9. This negative turns positive, 9 pi over 4. So combining those terms, 7 minus 2 is 5, 5 minus 9 is -4, plus 9 pi over 4. That right there is the answer to my integral that I started with of integral of -6 to -2 f of x dx. All right, moving on to B. They are asking us to find and evaluate an integral from 3 to 5 of this expression. So what I want to do is break this apart using some rules and properties of integrals. So what I'm going to do is say that this thing that I'm trying to find is equal to 2 times the integral from 3 to 5 of f prime of x plus the integral from 3 to 5 of 4 dx. Okay, well, what is the integral from 3 to 5 of f prime of x dx? Well, using the fundamental theorem of calculus, this is just 2 times the integral of the derivative is just going to be the function itself, but evaluated between the limits of 5 and 3. So this becomes f of 5 minus f of 3. And this right here obviously is going to be 4x evaluated from 3 to 5. Okay, so what is this? Let's keep going. 2, well, the function f of 5, I have to come back to the graph and see, well, what is f of 5? Well, f of 5 is 0 right here. So if I if I erase this, we can see this a little more clearly. Go back to the original function here. Yeah, so f of 5 clearly is 0. So moving back here, this tells me then that this is 0. Well, f of 3, here's where this part comes in that we were probably wondering, why did they tell us this? F of 3 is 3 minus root 5. So this is minus 3 minus root 5. Okay, and this evaluates out to 8. Right, we kind of knew that. This is a height of 4 with a difference of 2. This ends up being 20 minus 12, or 8. So this is 2 times negative 3 plus root 5 plus 8. This would be negative 6 plus 2 root 5 plus 8. That is equal to a final answer of 2 plus 2 root 5. That ends up being my final answer for the problem that they gave us. All right, let's move on to C. It says the function g is given by g of x is equal to the integral from negative 2 of x f of t dt. Find the absolute maximum value of g on the interval negative 2 to 5. Justify your answer. Okay, well, I need to find the absolute maximum of g. So I'm just going to state this. I need to find, one thing I know is I need to find the critical points of g. Okay, I'm going to find critical points of g because that's going to be a candidate for the absolute maximum. It is a closed interval, so that means I have to consider my endpoints too if I'm trying to find the absolute maximum over this closed interval, right? So the candidates that I have are going to be negative 2 and 5 and any critical points that I can find. So how do I find critical points? Well, I find critical points by taking the first derivative and setting it equal to 0. So what is g prime of x? Well, g prime of x is going to just be f of x, right? F of x by the fundamental theorem of calculus. So g prime of x is f of x. So I have to then say, okay, critical points are where f of x is 0. So where's f of x equal to 0? We got to go back to the graph and look. Where does this thing cross the x-axis? It's going to be at negative 1, 1/2, and 5. Okay, so that is going to be at x equals negative 1, a positive 1/2, and 5. But we've already considered 5. That's the endpoint, so that's already on our list. So I'm going to add in negative 1 and 1/2 as my candidates. Okay, so our job then is to find g of x for these values and see which one is the maximum. Okay, so if I take g of negative 2, integrating from negative 2 to negative 2, right? Here's what I'm using to find out what g of x is. I'm using this integral. Well, if I integrate from negative 2 to negative 2, that's a 0. Okay. If I take the integral, let's just start making a list here. Right. G of negative 2 is the integral from negative 2 to negative 2 f of t dt. That's 0. If I want to know what g of 5 is, I have to take the integral from negative 2 to 5 f of t dt. And what is that answer? Well, that's going to be, going back up here, looking at -2 to 5. Okay, well, that's going to be basically what we found inside right here. It's basically all of this part here. So it is going to be 2 plus 9 minus 9 pi over 4. So that's 11 minus 9 pi over 4. So again, if you're not sure about that, you can go back and take a look at that. But this is just finding all of the areas from -2 to 5. So that's what we've got here. So this is 11 minus 9 pi over 4. If I want to know what g of -1 is, right, I'm integrating from -2 to -1, f of t dt. So if I go back and look at the integral from -2 to -1, that's 0. We already determined that. Let's see, -2 to -1. Oh no, -2 to -1 is a positive 1/2, right? Base 1/2 base times height. So that's a positive 1/2 using geometry. It's just the area of that rectangle. So that is a 1/2. Okay, that's a 1/2. Let's make that a little neater. So this is a 1/2. And then if I want to find out what g of 1/2 is, right? So g of 1/2 is equal to the integral from -2 to 1/2. So we go back up and look at what that is. -2 out to 1/2 is a -1/2, because these two areas will cancel, and I'm just left with this negative area, which is 1 by 1/2 times 1/2. So that's actually a -1/4. So this ends up being a negative. It's negative because that triangle was underneath the x-axis. All right, so which is the largest value? Well, 9 pi over 4. All right, if we use 3 for pi, 27 over 4. So most certainly this is going to be the largest value, because this ends up being maybe around 4 or 5. So that really is my answer. So I'm going to write that as an answer over here and say that the absolute max of g of x from the interval from -2 to 5 is 11 minus 9 pi over 4. Now this question was asking us specifically, find the absolute maximum value of g on the interval. So they wanted me to answer what is the maximum value. This is the maximum value, and obviously it occurs at the endpoint of the interval at x equals 5. Okay, next question. This ends up being maybe one of the longer videos on this 2019 FRQ. Part D is find the limit as x goes to 1 of 10 raised to the x minus 3 times f prime of x all over f of x minus arctan of x. All right, well, I'm going to try substitution, right? That's the first thing that we try when evaluating this. So what I'm going to do is I'm going to try direct substitution. I get 10 to the 1 minus 3 f prime of 1 all over f of 1 minus arctan of 1. Okay, well, 10 to the 1 is 10. Well, if f prime of 1, that would be the slope when x is 1 up here. So when x is 1, we need the slope of this line. So delta y over delta x, this is 4 over 2. That has a slope of 2. So that means f prime when x is 1 is 2. So it looks already this is not a L'Hopital's rule problem. All right, well, what's f of 1? Going back to the graph again. F of 1 is 1. It's right here. So f of 1 is 1. And the arctangent of 1 happens to be pi over 4. Right? Whose what angle has a tangent of 1? That's the question that arctan of 1 is asking us, and the answer is pi over 4. So basically I can answer this as a final answer of 4 divided by 1 over pi over 4, and if you want to simplify that you can, but you can leave this just as it is as a final answer. No explanation is needed. I hope this video was helpful. Check out my other videos on the 2019 FRQs.